Okay, in this video, I found more examples, and we're going to go through the opposite with our prefix system. So again, these are typically covalent, and they are only using nonmetals and nonmetals. And in a previous video, I showed you the symbols and formulas, and we turned them into names. Now we're going to take the names and turn them into symbols and formulas. And again, we don't even have to use the crisscross method here. We don't have to look up oxidation numbers. The only thing we have to use is our prefixes and know our symbols. So for example, if there's no symbol or no prefix in front, I'm just going to use the regular symbol. So sulfur becomes S. Dioxide, oxide is from oxygen, di is 2. So SO2. Okay, if we look at phosphorus trichloride, phosphorus, there's nothing in front of it, so that's P. Trichloride, tri is our prefix for 3, Cl3, 3 chlorines. Now, if we look at this example, there's a number, or a prefix, for a number in front of bromine, and then also we have oxide. So you have to be careful of these and make sure that you don't miss any of these. So bromine is tri, Br3, and oxygen or oxide is 8, O8. We talked about carbon monoxide. I gave that as an example in the previous video. So our mono is 1 carbon, so 1 carbon and 1 oxygen. If we look at manganese dioxide, there's a 2 there. Manganese is Mn, oxide is O2. Now, I, of course, recall a lot of the symbols a lot faster than you. I've been doing it a lot longer. You may need to use your reference table or look up what the symbols are online. If we look at this one, tetraphosphorus decoxide. So we have tetra and we have dec in front of our names for the prefixes. Phosphorus, of course, is P. Oxide is from oxygen. Tetra is my prefix for 4. Dec is my prefix for 10, and that's it. This should be very simple when we go through. If you see prefixes, you do not need to use the crisscross. You do not need to use oxidation numbers. You only need to understand what the prefixes are. And a lot of these prefixes should be pretty common to you from math classes and other science classes. There's maybe some that you're not familiar with, but again, it should be pretty straightforward. You should become very familiar with mono, with di, with tri. Tetra might be a little bit different with 4. Pent, for example, you've learned about pentagons or hexagons in math class, 5 and 6 side objects. And so it should be pretty straightforward taking the formulas that have prefixes and giving the actual formulas. So you do have to make sure that you're just doing that and nothing else. It doesn't mean that you then take oxidation numbers or create a Roman numeral system and then go above and beyond and make matters worse. It should be pretty straightforward. So if we look at a couple others, carbon tetrachloride, I did that an example in a previous video. We have tetra here, so carbon does not have anything, that's just 1 by itself. And then chloride is chlorine, there are 4 of them. Silicon dioxide, silicon is Si. We have di for oxide, SiO2. And so again, I don't have to do anything else. This is pretty plain and simple. It should come very easy. I'll do one more and then we'll call it a video here. So Dinitrogen Pentoxide. Dinitrogen is N2 because of the di, and then the pent for oxygen is 5, N2O5. And that is it. It should be pretty simple, should be pretty easy.